Hi everybody! I hope your day has been good so far. In this video, we will factor expressions. Factoring expressions requires you to think about all the things that we've been working on, like prime factorization, GCF, leftovers, etc. Now, I like to call factoring backwards distributing. Let's go ahead and jump right into an example so I can show you what I mean. We have here the binomial 3x plus 6. The first thing, in order to factor this, we're going to find the GCF of 3x and 6. Now, if you know your GCFs, in this case the GCF is 3. And we're going to pull that 3 out of both terms. So once we've pulled that 3 out, I'm going to put my leftovers in parentheses. Now when I take 3 out of 3x by dividing, of course, I am left with x. When I take 3 out of 6, I am left with 2. So, 3x plus 6 in factored form is going to be 3 times the quantity x plus 2. Now the reason I call this backwards distributing is because once we have our answer, we can check it by distributing. You used to be given problems that look like this and have to distribute. 3 times x is 3x, 3 times 2 is 6, and it brings us right back to our original problem. All we're doing is doing it backwards. Try this example, 4x plus 12, and factor it on your own. Then come back to the video and we'll go through it. Okay. So once again, we're looking at our binomial 4x plus 12 and finding the GCF so that we can take it out. The GCF of 4x and 12 is 4, because 4 divides both terms evenly, and it's the biggest number that does that. When we take 4 out of 4x by dividing, we're left with x. And then if we take 4 out of 12 by dividing, we're left with 3. Let's go ahead and check our answer. 4 times x is 4x. 4 times 3 is 12. And it brings us right back to our problem. So we just factored, aka backwards distributed, whatever you would like to call it. That is how we factor. Let's move on to another example. In this example, there is a variable in both terms. We have the binomial 8x squared plus 12x. Let's use the same steps and factor this. We are looking for the GCF between 8x squared and 12x. Now 4 is the greatest number that can go into both 8 and 12. But now since they both have variables, we have to consider that as well. X squared and x. They share one x. So they both have an x. Now let's take our GCF and pull it out of each term. When we take 4 out of 8 by dividing, we're left with 2. And when we take x out of x squared, we're still left with an x. Now let's do it to 12x. When we take 4 out of 12, we are left with 3. And we're taking x out of x, and we have no more x's left. So this is our answer in factored form. Let's of course go ahead and check our answers. 4x times 2x is 8x squared. 4x times 3 is 12x. And that confirms that we are correct. Go ahead and pause the video and try the next one. Then come back to check your answer. Alright, as always, to factor 9x squared plus 27x, we are going to look for the GCF of both of these terms. So looking at our coefficients, 9 and 27, the GCF is going to be 9, because 9 goes into both evenly. And looking at our variables, x squared and x, they share 1x. So 9x is going to be our GCF. Let's pull it out. When we take 9 out of 9 by dividing, we're left with 1. And we're taking x out of x squared, we're left with x. Now let's do it to 27x. 27 divided by 9 is 3. And we're taking x out of x. There are no more x's left. So our factored answer is going to be 9x times the quantity x plus 3. Checking our work, 9x times 1x is 9x squared. 9x times 3 is 27x, and we are correct. All right, moving on to another example. We have the binomial 3x squared y plus 15xy. We're going to use our same exact steps. Step 1 being finding the GCF of 3x squared y and 15xy. So looking at our coefficients, 3 and 15, the GCF is 3. Looking at our x's, x squared and x, they share an x. Y and y, they also share a y. So our GCF is 3xy. Now we're pulling it out. When you take 3 out of 3, we're left with 1. Taking x out of x squared, we're left with x. Taking y out of y, there are no more y's left. Now with this term, when we take 3 out of 15, we're left with 5. We're taking x out of x, no more x's. Taking y out of y, no more y's. And this is our factored answer. Let's check it. 3xy times x gives me 3x squared y. 3xy times 5 gives me 15xy. All right, go ahead and pause the video and try the next one on your own, then come back to check your work. Okay, as always, we're following the same exact steps. So finding the GCF of 15x squared y and 20xy. GCF of 15 and 20 is 5. And just a side note, if you still need to make your factor trees to do that, that is totally fine. I'm just doing this for the sake of timing. So the GCF of 15 and 20 is 5. X squared and x, they share an x. Y and y, they both have a y. So 5xy is our GCF. Now we're taking that out of 15x squared y, so 15 divided by 5 is 3. X squared divided by x, there's 1x left. Y divided by y is 1, so there's no more y's left. 20 divided by 5, so when you take out 5, you get 4. You're taking out x from x, there's no more x's left. Taking out y from y, no more y's left. So here's our answer in factored form. Checking our work, 5xy times 3x gives me 15x squared y. 5xy times 4 gives me 20xy. And that confirms our answer. All right, now don't get scared just because there are 3 terms. We're doing the same exact concept, except with trinomials this time. So follow along. Our first step is finding our GCF and pulling it out. So 10, 15, and 20, our GCF with our coefficients is going to be 5. Okay, this one has x squared, x and x. They share only one x, right? Because they all have one x. Even though this has x squared, this one doesn't have x squared, and this one doesn't have x squared. They have to share it in common. Looking at the y's, y, this one doesn't have a y, but this one does have a y. they don't share any y's because this middle term does not even have a y. So 5x is our GCF. Let's pull it out. When you take 5 out of 10, you're left with 2. X from x squared is x. And you're taking nothing away from the y, so that stays there. Minus, taking 5 out of 15 leaves you with 3. Taking x out of x, there are no more x's left. Now, taking 5 out of 20 leaves you with 4. Taking x out of x leaves you with no more x's, and you're taking nothing out of y, so the y again stays there. And that would be our answer in factored form. You can check that on your own if you'd like to confirm that. Once again, pause the video and try this example, then come back to check your work. Alright, once again we are doing the same exact process. The GCF is the first thing we are finding. GCF of 2, 16, and 30 is going to be 2. Again, if you need to do your factor trees for that, that is no problem. This one has x squared, x, and x, so they share just an x. There's a y, and nope, this one doesn't have a y, so they don't share it. So that means that 2x is our GCF here. When you take 2 out of 2, you're left with 1. When you take x out of x squared, you're left with an x. You're taking nothing out of y, so that y is still there. Taking 2 out of negative 16, or 16, leaves you with minus 8. Taking x out of x, no more x's left. Nothing out of y, left with y. Now you're taking 2 out of 30, you're left with 15. Taking x out of x, no more x's left. This is our answer in factored form. Alright, thank you for following along, and great job. See you next time.